If you put a balloon filled with air over one candle and a second balloon filled with water over a second candle, what would happen? Would they both pop? Would neither pop? Or would only one pop? We put these questions to the test.
As you can see, when the balloon is filled with air, the flame burns a hole in it. When we added some water to the balloon before putting it over the flame, the balloon did not pop.
The reason a balloon filled with air pops when you put it over a flame is because the rubber of the balloon gets very hot and weak and then breaks. When you fill a balloon with water instead of air, the water absorbs most of the interactions between the candle molecules and the balloon molecules, so the rubber doesn't get very hot. Water has a very high heat capacity, much higher than air, so it will keep the balloon from bursting.
The balloon with water is colder than the balloon with air due to the fact that water molecules are less spread out than air, so the external force is going to spread out over more molecules. Thus, each molecule experiences less of an external force.
Using the equation FAT less of an external force per molecule uses a smaller change in momentum, meaning the molecules do not move as fast after the interaction as compared with an air-filled balloon. Thus, the temperature of the balloon is colder than that of an air-filled balloon.
When we put the candle went out and it was suctioned up to the balloon. The candle goes out because it doesn't have oxygen anymore, which is needed in order for the reaction to create the flame. No candle flame means pressure in the candle goes down and is less than the pressure in the balloon. Since pressure goes from high to low, pressure from high in the balloon tries to go to the lower pressure in the candle, which allows it to stick to the candle and creates the suction-like effect.